Hi there, folks. In this lesson, we're looking at adding and subtracting rational expressions, and this is the second installment of this lesson. But remember, when we did this before, adding and subtracting rational expressions, all we had to do was find common denominators. Then we would add or subtract the numerators, leave the denominator the same. And then the last thing we always check is if we can reduce our fraction, okay, reduce that final answer. And really, the only difference here in terms of the difficulty level, we're going to take this up just a little bit in terms of the difficulty, and really that's going to be focused on finding the common denominators. Okay. So far, the examples we've looked at, the denominators have been relatively easy to find because everything was already in its factored form, and we just had to identify the factors that each fraction was missing, and then multiply accordingly. All right. Today, we're going to look at ones that aren't in factored form to make it a little bit more difficult to identify those common denominators. For example, if I look at this first one, it's not in factored form, and really here, it's really difficult for me to see the common denominator. When I look at this, I see one that has an x minus 9, the other has an x squared minus 8x minus 9. I can't just identify the pieces that aren't the same here and multiply accordingly. I mean, these things are completely different as they stand right now. So I guess what we could do, and I'm going to show you a different way, I could multiply this first fraction by the x squared minus 8x minus 9 over itself. But you see right away the issue that this is going to cause as I try to navigate multiplying this trinomial times the binomial, and I'm going to have a mess of terms here. And really, it's the same thing when I multiply this second fraction by an x minus 9 over x minus 9. And really, I'm going to have so many terms, and then trying to factor this thing at the end and reduce the fraction is going to be almost impossible for us. Okay? So instead of doing that, that will give me common denominators. But what we're going to do is we're going to look for the least common denominator because that makes the problem easier. All right? In order to identify the least common denominator, I need this thing to be in factored form. So here's what I'm going to do. I'm going to factor this thing completely. And really what I want to do is factor the denominators. Okay? So I factor these denominators. This denominator I can't do anything with. X minus 9, it's already as simplified as it can be. Over here, the x squared minus 8x minus 9, I could factor this. I build a bridge. It's a negative 9. The two numbers that multiply to negative 9 but add to a negative 8 are a negative 9 and a positive 1. And so that's going to factor into an x minus 9 and an x plus 1. And now as I look at this thing, I can see that they have something in common. This has the x minus 9. This has an x minus 9 and an x plus 1. So if I want these denominators to be the same, this first fraction needs that x plus 1. See, now it'll have the same two factors as the second fraction. It'll have the x plus 1 and the x minus 9. Once we have the same factors, now I have common denominators. Okay? So I have to factor it first in order to identify the factors that each is missing. Now I can multiply this all out. Here I've got to multiply out the x plus 1 times the x plus 2 using my distributive property. That's going to be an x squared plus 2x plus 1x plus 2. The denominator, once again, I'm going to leave in that factored form. 1 because it's easier, and 2 because I'm going to try to factor this thing at the end anyway. The only reason I have to multiply out the numerators is so that I can identify and combine my like terms. And now from here, I can add those numerators. I'm just combining like terms. In this case, I've got these two are like terms, these guys are like terms, and then these guys are also like terms. So I'm combining these like terms. That's going to give me a 2x squared. Looks like I also get a plus 3x. And then the positive 2 and the negative 2 cancel each other out. And it's all over the x minus 9, x plus 1. And I can try simplifying this. I can try reducing it. The numerator I could factor an x out of. But it turns out that doesn't really do anything for me in terms of reducing. I can leave my answer in this form if I'd like, or I can leave it in this, factored form. Okay? If I look at the next one, again, I can't really identify the least common denominator here unless I put this thing in factored form. So I'm going to factor each of these denominators. This first one factors into an x minus 4 and an x plus 2. We build a bridge. Two numbers that multiply to a negative 8 but add to a negative 2. In this second fraction, I build a bridge. It looks like it's going to give me an x minus 4 and an x plus 3. And so now when I look at these denominators and say, okay, which factors do they have in common? Which do each of them need? This one has an x minus 4 and an x plus 2. This one has an x minus 4 and an x plus 3. That first fraction, the only factor it doesn't have is the x plus 3. See, if I give him that extra factor, now it'll have the same factors as the second example. And the second fraction here, the factor that it's missing, if I look now, this first fraction has the x plus 3, the x minus 4, and the x plus 2. It's only missing the x plus 2. So basically, I just give each fraction what the other one has so that everything's fair, so that each fraction has all the same stuff. And now I can multiply this out. So I multiply out that numerator. When I multiply out the numerator, again, I'm using my distributive property. That's going to give me an x squared minus 1x plus 3x minus 3. The denominator I just leave in this factored form. Over here, I'm going to use my distributive property again. That's going to be a 2x squared plus 4x. The denominator I just leave in the factored form, and really it doesn't matter what order I write these in. I'm just going to write them in the same order that I wrote the first one, just for a little bit of consistency. And now from here in those numerators, I combine all the like terms, the negative x, the x squared and the minus 2x. And again, this subtraction I might change to adding the opposite so that I don't make any sign errors here. The x squared and the minus 2x minus 2x squared give me a negative x squared. The negative x, the positive 3x, and the minus 4x give me a negative 2x. And then the negative 3 doesn't have anything to combine with, so it just stays the way it is. All right. My denominator is still just staying in factored form. I just write all three of these factors down. And that's essentially it. From there, I can try building a bridge and factoring that numerator, but it's not going to factor, and this thing is not going to reduce. So that's it. All right. So again, when we have this and we're trying to look for common denominators, factor everything completely, then identify the common denominators by looking for which factors each fraction needs. Multiply out the numerators, add or subtract, denominator stays the same. Okay?